All right, well, welcome everybody to our keynote presentation. Are you really more secure, or can you really be more secure in the cloud? So I'm Ken Hartman. I'm a certified instructor here, and I teach the SEC 510 public cloud security course for AWS, Azure, and Google Cloud Platform. I also teach SEC 480, our Cloud Security Essentials course. So in addition to this, I'm also a content contributor to the SANS Cloud YouTube channel. And one of the projects that I've worked on in the past year is the Head in the Clouds video series. And these are a collection of short videos on various topics that will help SANS students fill in the gaps in their knowledge, because when they come to one of our courses, we assume a certain amount of knowledge. So this is a great way for folks to get up to speed. So one of the reasons why I'm mentioning it right up front is because I may allude to a couple of these videos in my talk tonight. I want to tell you a story about how you really can be more secure in the cloud. But every story needs a hero or a heroine, as the case may be. So this story is about a security leader. Let's call this leader by their nickname, Stormy. Well, Stormy has a problem. Management is sold on the cloud. They probably read about the cloud in their in-flight magazine or heard that all the cool kids are doing it. No, I'm just having a little bit of fun here, but anyway, Stormy is concerned that management may not fully appreciate what they're asking for. Or maybe they do, right? They sat Stormy down and went into great length about everything that was riding on this quote unquote digital transformation when they assigned it to Stormy. Well, every story needs a villain. Well, let me introduce you to ours. This is the big, ugly, hairy monster that we call fear, uncertainty, and doubt. Fear of losing credibility, fear of being blamed for incompetency, and fear and feeling like the need to fake it. Some call this the imposter syndrome. Well, there certainly is lots to know and learn about the cloud, such as being overwhelmed by the marketing messages that we hear, and the fact that the default configurations are typically insecure. We've been talking about that this week in my SEC 510 class. And the major cloud service providers have an overwhelming amount of services to keep track of. Plus, each service is being updated on a very frequent basis using agile development methods. So I'll teach a class 1 week, things will be one way. I'll teach it the second week in a row, and things will have changed slightly. Screenshots are out of date, and we have to scramble as authors to keep that content up to date. But underneath it all is this nagging question: can the cloud be properly secured so that I can trust my company's sensitive data with that cloud service provider? Well, Stormy, like any responsible security professional, feels the weight of this burden. Stormy, like the typical InfoSec pro, is empathetic and cares deeply about their company. Stormy recognizes that help is needed. And just at the right time, Stormy remembers about SANS and hears about the SANS Cloud Security Curriculum. Well, at this point in Stormy's exploration, it may not be completely clear exactly how providential this encounter will turn out to be. But as the ancient proverb states, when the student is ready, the teacher will emerge. And fortunately for Stormy, management is willing to invest in SANS Cloud training. Now, in the SANS Cloud training, we have helped hundreds of students learn how to secure their cloud environment and gain the skills necessary to drive the change in a secure direction. The SANS Cloud instructors, we understand the weight of this responsibility, and we've felt it ourselves. And in fact, the SANS Cloud team has put together a flight plan to guide folks along this transformational journey toward becoming what we call the SANS Cloud Ace. And SANS, as an organization, has literally helped thousands transform their career and get equipped to tackle the challenges of the job. I'm one such example. I'm an alumni of the SANS Technology Institute. I got my master's in information security engineering back in 2018. And as part of that, became a GX security expert. So I'm speaking here from experience. Now we know that not everyone will jump in and take a SANS course right away, and that's okay. After all, why would you want to take a test flight, or why would you want to enroll in a flight school without taking a test flight? So the SANS Cloud team has a slew of free resources, including our YouTube channel, which I've already mentioned. And we have a brand new podcast with multiple episodes already, and a Discord channel. So we've also got our summits, just to name a few of the resources. And these really are more than just resources. It's about joining a community. In fact, when I'm at a SANS event like this, I feel like I'm with my tribe, my community. So if a person like Stormy were to become a cloud ace, can you imagine what they would learn along the way? Well, I will tell you. But first, I want to give credit to the name of this talk to a friend of mine, a lady named Terry Radico, who wrote a blog post about this very topic about 5 years ago. Can you really be more secure in the cloud? Well, yes. And now I'm going to tell you why. In fact, I'll give you 10 reasons. So think of this talk as a teaser that will get covered in much more depth in the various SANS cloud courses that you could take. Number one is the API first cloud control plane. So this really is just a fancy way of saying that I can query the infrastructure and it will tell us about the resources configured therein. In fact, every API call is logged, so we can determine who's making what changes to our cloud configurations. And when I say every API call is logged, what I mean by that is every call that is made by the web console, the command line interface, software development kits, or even other tools. In fact, even when other cloud services call other cloud services on our behalf, that all leaves a log. And of course, each of these API calls requires strong authentication. And with the identity and access management service, we can have granular access control over who can make which particular API calls. And here is an example of an AWS command line interface call to list the virtual machines in a particular region. Or I can get really fancy and I can use a single line of code and iterate through all the AWS regions and output the desired information in the form of a table. Okay, so at this point, you might be asking, what's the big deal about being able to query the infrastructure? Well, remember the CIS controls? They're still applicable in the cloud. Also, check out the CIS Controls Cloud Companion Guide. It's available as a free download on the CIS Controls website. Control number one, inventory and control of all enterprise assets. So in the cloud, we can just run a query, and I can tell you that this is much harder to do on-prem. Critical control number two is inventory and control of all software assets. Now in the cloud, everything is software defined. So I kind of make a shortcut and just say inventory all the things. And we're not just talking inventory, we're talking about looking at the configuration of all of these cloud resources as well. For number two, I chose pay-as-you-go billing. And In the cloud, you pay for what you use, but you only pay for it as long as you're using it. When you're done using it, you free up those resources, and then they're available for other tenants to use. Therefore, since we're charged for what we use, our billing history is very detailed, and it is another log that we can use to correlate, to detect fraud and abuse, and possibly even identify abandoned systems. One of the things that I tell my students is systems that are no longer managed are quite likely no longer secure, if they ever were in the first place, right? So we've kind of come a full circle from the 80s when the Cuckoo's Egg was written. If you haven't ever read this book, you definitely want to check it out. So this was written about the time frame in the back in the 80s, and I think it was published in 1990 about a Linux admin who investigated a 75-cent charge and ended up discovering this elaborate maze of computer espionage. Hopefully that's not going to happen when you look at your billing history, but it's a powerful tool and highly underrated, I would say. I'm also going to mention that pay-as-you-go billing is awesome for learning, right? Because we can experiment and we can test things out. So I can spin up a lab environment, play, and then when I'm done for the day, I just tear it down and I'm no longer incurring a charge. Number 3 is infrastructure as code. I put this at number 3 because, yeah, you can use the cloud without infrastructure as code, but there's so many benefits of using infrastructure as code. There's versioning, change control, change comparisons. I know who made the change and when they committed it. Another thing is infrastructure as code is idempotent. And idempotency means that I can run infrastructure as code multiple times and use it to maintain a particular configuration state. But if the configuration drifts when I rerun my infrastructure as code will put it back the way it's expected to be. One of the things that I've seen in my consulting practice is various clients of mine will deploy half their environment using infrastructure as code, and the other half they'll do manually. Or after they deploy everything by infrastructure as code, they'll go in and make a bunch of manual changes. That certainly is a recipe for chaos, because you want your state file that is when your infrastructure as code tool deployed everything, you want it to be accurate, current, and up to date. And then again, when you're done, you can just destroy all your resources. One of the very popular infrastructure as code tools is Terraform, which is created by HashiCorp. So if we want to launch a virtual machine, well, here is the snippet of code that we would use to do so. What this is saying is it's saying use the Ubuntu image, that's an AMI in AWS parlance, and we want to launch a T2 micro sized virtual machine. And then we can give it a tag, so in this case, we're giving it a name tag saying it's going to be SANS System 1 as an example. And then we can get much more elaborate. So on the left-hand side, I have a Head in the Clothes episode 10. Here's the URL for that, where I actually go step by step and make modular code to deploy an AWS virtual machine, an Azure virtual machine, and a Google Cloud virtual machine. And the components of the infrastructure are written as separate Terraform files. So I've got one for the network as an example, and one for the main Terraform file, another one for the key pair to SSH into it as an example. Now on the right-hand side, I've got a vars file, .tf vars, and here what I can do is I can customize certain things for the configuration. So in this example, I'm deploying to US East 1 in AWS and Central US in Azure and US Central 1 in Google Cloud, right? Each of these cloud service providers call their regions something slightly different. But with a couple modifications to just this file, I could deploy this in Europe or in Asia Pacific. So this is one of the reasons why we really like infrastructure as code. Another reason is because then I could deploy it to another environment and I have a test environment that is a true replica of what we're running in production. Some of the companies that have been associated with in the past, their test environment was not anywhere near like their production environment, right? Their test environment got all the hand-me-down systems. So how in the world was that a true test when their old hardware had outdated firmware and, I could go on and on. So a thought question for you. What if we could check our infrastructure as code for security vulnerabilities before we deployed it? Well, actually we can. And that gets me to number 4, policy as code. So just like we can create code to deploy our infrastructure on the compliance and security auditing side, we can write code to do our automated checks. And whenever we can reduce something to code, well, first of all, sometimes when we write a policy, there's ambiguity. Does the policy mean this or does it mean that, right? But if we want it to be enforced by automation, we have to be very clear. So by being able to have a policy or any code that can be tested, we're getting more clarity. The other thinking is that whenever we can reduce something to code, we're eliminating the potential for human error. Kind of going back to the infrastructure as code, if you're provisioning a server by hand, and then you have to do it again next month by hand, there's a chance you might have skipped a step on your checklist. Well, not so with infrastructure as code. Or when it comes to auditing or checking things from a compliance or security perspective, if we have automated that process, we're avoiding the probability for human error. When I was a young engineer, just out of college, I heard one of my mentors say, there's certain things you're going to do over and over again, somewhere in the neighborhood of 80%. And if you're going to do it over and over again, you should get very good at that. And I've added on to that philosophy that said, if you're going to do it over and over again, the best way to get very good at it is to automate it, because then you can iterate and learn upon your improvements. So there's multiple different tools that you can use to implement policy as code. Open Policy Agent is one that many of the large internet companies, I believe Facebook and Google, use Open Policy Agent from what I understand. HashiCorp has a tool called Sentinel for examining their Terraform code. My favorite one is Chekhov. Chekhov is made by a company called Bridgecrew, and it is a static code analysis tool. And it will look over the infrastructure as code files for multiple different formats. As an example, not only will it look at Terraform code, it will look at CloudFormation or Azure Resource Manager code, and it has a whole bunch of policies and checks. So one of the reasons why I'm so big on this whole idea of policy as code is because when we're looking at a file and maybe the file is missing a configuration such as enforce TLS true. As a human, we might miss the fact that it's not there, right? Something that's, if the configuration said enforce TLS false, our eye might jump at that, right? But it's harder to catch things that are missing in a file. So this is where static code analysis for your infrastructure as code tools really shine. Plus, it can be automated. One way to automate it, in fact, the preferred way to automate it, is to use it in a continuous integration, continuous delivery pipeline. So Continuous integration is the process of automating the part of submitting the code to the source code repository and having it checked, whereas the continuous delivery is pushing the code on out to a test environment, or in very mature companies, all the way on out to the production environment. So think about this. If we're doing it in an automated fashion every way, then the human error that could be introduced by doing a manual deployment goes to zero, because we're doing it the same way every time. As an example, I was at Google in the 2014-2015 timeframe. I wasn't a software engineer, but I was part of the engineering group. So as part of that, the culture there at Google was, well, if you find an issue, fix it. So I was over in Zurich and I was meeting with the team that did the vulnerability scanning internal to Google. And they were showing me this custom tool that they had created, and they had online publicly available documentation. And I was reading this later after I had met with this team, and I found a typo. So I could go into the source code repository, I fixed the typo, and I committed the change. And within 5 minutes, I was able to see that change out in production. And that's pretty cool. So think about what this does to the agility of a company by being able to make rapid, tiny changes on it's almost like a continuous stream of them. And it's for this reason that many companies have taken the position that anything that is not defined as infrastructure as code or pushed out using a CI/CD pipeline is technical debt. In fact, I would go even further. Because we can use a CI/CD pipeline to make any sort of changes that we need, perhaps to address a bug that we just discovered or some other issue that pops up, if there's any time that somebody needs to SSH into a system in prod to make a configuration change, well, that should be treated as an incident. I didn't necessarily say a security incident, but you should treat it at least as a service incident and do a root cause analysis. So why did my CI/CD pipeline fail us? Well, it's not so much that it failed, it is just I could make it quicker by, logging in. It is production after all. That's the type of thinking that we need to eliminate in order to be more secure in the cloud. So there's multiple different benefits to using a CI/CD pipeline. Before our session tonight, I was talking to a student who's taking Sec 540. So our Sec 540 class is all about security automation, and they go really deep into using CI/CD pipelines. So pushing code to production should not be a stressful event. I'm thinking about the deployment of hospital information systems, where they'll do a big bang deployment once a month, and it's all hands on deck, and they basically block off the whole weekend to do that. Where here, product updates are a typo or a bug fix. Not only that, we can use our CI/CD pipeline to do testing so that when it actually gets deployed out to production, we know that there's a very high likelihood that that deployment will be successful, because it's a small change. Small is beautiful. And if it's not, we can roll it back with a mouse click or a push of the button or a command. So here in the CI/CD pipeline, we can also lay in our security tools, right? So we might want to do static application security testing in the build phase. And we might want to do dynamic code analysis during the testing phase. So we can dream up security tests and get them added to the CI/CD pipeline. And it's an iterative, right? So as we learn, so maybe we discover that something actually broke while we can make the appropriate change. One of the cooler things that I've been involved with recently for SANS was their 2022 DevSecOps survey. And in this survey, what we'll do is SANS has a pretty impressive mailing list, as I'm sure you all know. So they'll segment this mailing list and they'll send a survey. Hey, would you like to participate in this particular survey if you're in that particular market segment? And we've been doing this survey for the past several years. So in this example, our earliest data was 2017. And what we're seeing is that there is a trend toward greater frequency of delivery, to the point where many of the companies are saying that they're doing it continuously, if not daily. And many are doing it on an at least weekly basis. So if there's this frequent pushes being sent out to production, how is a small security team able to perform the security assessment, which should be happening before you push your stuff out to production? The only way to do it is via a CI/CD pipeline that has your security checks integrated right into it. Anybody a fan of XKCD? So here is a fun XKCD comic, and it really gets at the truth, right? So if we do a task on a frequent interval and it takes us X amount of time, well, if we just invested X amount of time to automate that, we would save, we would get that return on investment. But I like to use this chart to make another point. So let's say we spend our 5 hours to automate a task that needs to be done yearly, but it takes us an hour to do it. What if we can, what if we bite the bullet and spend that time, but then rather than doing that task yearly, we can do it now 50 times a day? That is ROI, right? So we can do this with our automation. Number 6, as I was thinking about this top 10, I put as immutable infrastructure. So if your company is already using containers, you probably get the idea of an immutable infrastructure. If you need to make a change to that container, you're not going to SSH into it. What you're going to do is you're just going to publish a revised version of that image, and then you'll launch a replacement container and kill off the older versions, right? Just a kind of a rolling update. Well, we can do the exact same thing with our virtual machines, whether they are hosting containers or they're performing any other duty. So one of the things that I do when I'm working with a client is I look at the age of their virtual machines in each of their regions or each of their different cloud environments. Because let's say your organization says, we're going to have all critical vulnerabilities patched within 30 days. That's actually a pretty liberal time frame. Well, then what you could do is you could say, well, we're no longer going to allow a virtual machine to live longer than 30 days. And what we're going to do is we're going to have fresh images for that virtual machine made on a very frequent basis, perhaps once a day. So whenever we do need to replace out that old aging virtual machine, we're going to use one with a freshly baked image. So again, if ever you're needing to do this manually, you would do a root cause analysis. So you shouldn't need to SSH in and change your published virtual machine. You should treat that also as immutable. And then if somebody does change it, that's a security incident. After all, how do we detect that an intrusion has happened into our environment? There was an unauthorized change made. So what I say is electrify the fence. If even a quote unquote well-meaning site reliability engineer goes in and makes a change that didn't go through the hardening process or through the CI/CD pipeline, treat that as an incident, do a root cause analysis, so that way you can hold a very firm line that any change that was not pre-approved and made as part of our automated process, that's how we detect intrusions in our cloud environments. There's a variety of different tools that we can use to automate the image baking process. The goal that we're after here is we want to avoid having to apply patches in place in production. If you've ever done patching to systems in production, you're kind of sweating it, right? The last thing you want to do is to have that patch break the server. By automating the patching and application deployment process, the moment it hits production, it has already ran through the gauntlet. You've applied all the patches, you've applied the application, it's configured the way that it needs to be, and it's went through a whole battery of QA tests. So hopefully you're sold on some of these concepts. Another thought question. Well, how does one manage cloud security at scale? Companies are putting more and more of their mission critical workloads into the cloud. They're also putting more and more data into the cloud. They're also using more cloud service providers. One of the things that we saw during our DevSecOps survey was that somewhere less than 20% said that they were going with a single cloud service provider, and that most were using all three. So that creates a challenge for the security professionals, the security team. One tool that companies can use is called Cloud Security Posture Management. And this is a class of software, kind of like ERP systems or what have you. It's a class of software coined by Gartner, by the way, as part of their analysis and in leadership magic quadrants, right? So, but a cloud security posture management tool is continuously monitoring all of your different cloud environments. So the modern cloud security posture management tools can look at AWS, Azure, Google Cloud, and some of the other cloud service providers. They can look at multiple AWS accounts, multiple Azure subscriptions, multiple Google Cloud projects. And if there's anything that is out of compliance with a policy, it will get flagged. It can send you an alert, or if you give it permission, it can even perform some limited automatic remediation. Of course, we also say don't get carried away with the automatic remediation. Otherwise, you might be creating a problem. As an example, you might have one process that spins up a virtual machine, or it might say, the process might say, I want to keep 2 virtual machines running. But then as part of your automatic remediation, if the virtual machine is not compliant, shut it off. Can you see how this would be a big circle jerk? So some of the typical capabilities of cloud security posture management is we can use it to generate inventories, right? Remember, critical control number 1, have an inventory of all your stuff. And it can also help us enforce various control frameworks, such as, I don't know, the PCI data security standard or FedRAMP controls as an example. And it will monitor your storage buckets, right? So over the years, we've heard various media stories ad nauseum about S3 buckets that expose sensitive data, right? Like credit cards or health information. So that is the whole purpose of cloud security posture management tools. One of the leading vendors in the space is Palo Alto's Prisma product, but there's a great open source one as well, Cloud Custodian. This was originally an open source project originated by Capital One. It's written in the Python language, and originally it only supported AWS. Now it supports Azure as well as Google Cloud platform as well. But what we like about it, very much the same way that the infrastructure as code is abstracted away from the tool that implements the deployment of that infrastructure as code. With Cloud Custodian, the policies are written in YAML and they're abstracted away from the software that actually enforces it, right? So this way we can put our YAML files into a source code repository and version control them. And it can do a variety of things. For example, it can apply tags, it can do automatic remediation and so forth. So if you wanted to try this, it's very easy to deploy. The documentation is quite well done. But on top of that, there are security services from the cloud service providers as well. AWS has Security Hub. Azure had Security Center, but they rebranded it as Azure Defender for Cloud. And then there's the Google Cloud Security Command Center. These don't really purport to be cloud security posture management tools, but they do help you with cloud security posture management plus other stuff. So one of the resources that SANS has created is this cloud security service matrix, because one of the things that you can get lost with in the cloud is, well, AWS calls it this. For example, AWS calls their virtual machines EC2 instances, Elastic Compute Cloud, whereas Azure just calls them Azure Virtual Machines. But Google calls them Google Compute Engines. So it takes a little bit of time to get used to the different branding that each of the different cloud service providers have come up with, which frankly, I think can confuse people. We can also use a variety of different tools to assess our security posture. There's multi-cloud tools such as CloudSploit by Aqua or Scout Suite by NCC Group. So for example, well, and some of these have a commercial as well as a community version. For example, with Scout Suite, we can run it, let's say I'm hired to do a cloud security assessment. I might run Scout Suite to see what it is that I'm working with. But of course, we have to grant the Scout Suite the permission to be able to evaluate the particular cloud environment. And then there are some cloud-specific ones as well. Number 8, I'm going to say cloud workload protection platforms. So we all feel like, well, we should probably have anti-malware on our server. We should probably have a logging agent on our server. We should probably check our server for compliance with the hardening benchmarks. And maybe we want a tool that we can use for incident response. But all these agents that we would install on our virtual machine consume system resources. And don't forget, in the cloud, we pay for what we use. So if you stacked a whole bunch of agents onto a virtual machine, you're now saddling it with a bunch of additional overhead. So the idea behind a cloud workload protection platform is to bundle all these agents into one agent to meet all the needs. But that kind of oversimplifies it, because cloud workload protection platforms they're more than just that agent that you install on a virtual machine. They also will look at containers and say Kubernetes configurations and so forth. So here is a screenshot of the Microsoft Defender for Cloud. And what I'm highlighting here is that it's producing an inventory, and it says, oh, you've got some virtual machines without our agent installed. Yeah, so Microsoft Defender has an agent that you can install. And then they also tout how they're taking care of Kubernetes security as an example. So in this regard, Microsoft Defender for Cloud is not just cloud security posture management, but it's also got some of the things that Gartner would call the cloud workload protection platform. So where does that leave us? Well, we've got all these different terms. We've got cloud workload protection platform, cloud security posture management, and then they throw in some new buzzwords. And then they came up with a buzzword to group them all together called cloud native security platform. The point is that there's tools available to us to make sure that our cloud environment is properly protected. So as part of our survey that we just did, we wanted to know to what extent was cloud security posture management being used, and to what extent was cloud workload protection platforms being used. So most everybody said, yeah, we're using it. We're just not using it in all of our subscriptions or Google projects or AWS accounts. In fact, somewhere only 20% said that we're using it for at least 75% of our AWS subscriptions. And the idea behind that question is, well, some of the subscription or AWS accounts might be for the purpose of learning or testing or whatever, and we don't really need to do it. But I found this to be quite interesting. So this represents an opportunity. So of these various 10 items that I'm talking about tonight, they only help you secure your cloud environment if you take advantage of them. Number 9 was zero trust. Aren't you glad I didn't start off with this, right? So the idea behind zero trust is we verify every user. We make sure we understand which devices are trying to access our systems, and we're enforcing least privilege. So yeah, zero trust, right? I think it's quickly becoming a buzzword because everybody's so excited about it that they're talking about it at all these security conferences. But I'd caution you, don't throw the baby out with the bathwater. If you did want to come up to speed, I would check out Google's BeyondCorp white paper. How would you find this? Well, I don't know. You might use the Google search engine. But anyway, they did a lot. And the genesis of this, at least from my perspective, was the APT attack that occurred on Google back in the 2009 time period called Operation Aurora. And the attacker was basically able to move freely throughout the whole Google infrastructure. And I can imagine how devastating that was to the teams there, where they, as a group, said, this can never, ever happen again. And like I said, I was there in 2014, and they were still talking about all the different lessons that they learned. And while I was there, they deprecated VPNs, the client VPNs. So as a Googler, I didn't VPN into their infrastructure ever. We just connected over TLS, and we used managed devices. So they had different examples of trust levels. For example, they were also trying to do mobile first. So they wanted people to be able to do everything via their smartphone. So if it was a bring your own device without full disk encryption on the phone, it was least trusted. But if it had full disk encryption on the phone, but was a bring your own device, it had a little bit more because it had the full disk encryption. And at that time, there wasn't Pixel phones, but there was Nexus phones. So if it was a Nexus phone that was bring your own, it had even more trust. Then if it was a Google-owned Nexus phone, it had the most trust. So that's just kind of a quick example. Azure has conditional access. This is the Microsoft equivalent of the whole BeyondCorp philosophy that is now becoming prevalent, and a lot of people are adopting zero trust architectures. I have a very simple explanation for zero trust. If we have two systems, system A and system B, if system A doesn't need to talk to system B, well, then don't allow network connectivity. However, if system A does need to talk to system B, make sure that there's strong authentication between the two. So when we prevent this connectivity at scale, we would call this a service mesh, but it's basically this idea of microsegmentation. Another kind of funny story is when I was at Google, I was part of a team called Engineering Compliance, and we worked with their various auditors. And the auditors were expecting to see a 2 or 3 tier architecture. But, we spread out the architectural diagrams, and it was basically this mesh with all kinds of trust boundaries and segmentation. They're like, where's your 2-tier architecture? And it's like, that's kind of old thinking, because we want only the systems that should be able to talk to each other to be able to talk to each other. And that gets me to point number 10, which is software-defined cloud networking. Everything in the cloud exists as a file, and we can implement load balancers at the regional or the global level that can direct traffic to our services as needed. We can do API gateways or service meshes to control where the HTTP requests are directed based on the contents of the URI. We can create a virtual private cloud. So on this slide, I'm showing an example of a virtual private cloud, and it kind of spoke to me when I was looking for an appropriate image, because I think of a virtual private cloud as your private piece of the public cloud. So when you provision a virtual private cloud in one of your favorite cloud service providers, that's yours to do with what you want. You get to decide who and what is allowed to send traffic into that virtual private cloud. So as an example here, what we're showing is a VPN connection back to the enterprise network. And under this scenario, I may not even allow traffic from the internet into my virtual private cloud. So you can do all this, and we can create these little protected enclaves that allow us to do the compute and processing that we need in a very safe manner. And here is a diagram that shows, using the AWS symbology, how we can go about this. So yeah, we can have a public subnet, we can have a private subnet, we can create routing rules between the two. And if we do want to allow traffic from the internet, we can use an internet gateway. If we don't want to allow traffic from the internet, we wouldn't have an internet gateway, and we'd have basically isolated networks. And if we want to connect to our corporate office, we can use a VPN gateway, and again, configuring the routing as appropriate. But all of this is software defined and can be changed at basically a moment's notice. And then if we have services like S3, maybe we don't want that bucket that has our secret information in it to be exposed to the internet. Well, what we can do is we can use a private service endpoint. So that way that S3 bucket can only be accessed from within our specific designated VPC. So lots to like, so I'm using AWS as an example, but for the most part in Azure and in Google Cloud, it's very much the same. All right, so let's get back to our story. So what should Stormy expect at a SANS conference? Well, immersive learning, right? In some ways, we drop you into the deep end of the pool, but then we're there with you as your instructors or virtual teaching assistants, helping you learn how to swim. I also, when I'm talking about a SANS course, I tell people, don't think of it as just a week of instruction. Think of it as a semester-long course, especially if you're planning to sit for the certification, because that's the way we thought about it when we were in the SANS Masters course. Because what you want to do is you want to, go through the material when you're outside the stress and excitement of the week at the SANS conference. The other thing is we listen and we iterate based on what it is that we're learning. And we know that certifications are valuable to our students because we listen to the surveys. So we also help you get ready for that certification to prove that you're prepared to take on the challenges for the particular job that we've designed this course for. So every good story needs to have a call to action. So here's mine for you. Jump in and dive deep, participate and collaborate. Also, leverage that flight plan that the cloud security team has created to help you think about which SANS courses that you'd want and embrace this transformational journey with us. And then for those of you that are here at the conference this week, make the most of it. But I kind of feel like I'm preaching to the choir because you're here at 8 o'clock at night, making the most of this week. I'm sure you've probably heard about the free resources that SANS has, sans.org/free. And some of the contributions from the cloud security curriculum are in that. Also network with your fellow students, get to know your instructor, your virtual teaching assistants and facilitators. But I also feel duty bound to warn you about the bad things that could happen if your cloud is not secure. In June of 2014, there was a company called CodeSpaces that had their root credential stolen. And I don't know if it was discovered by brute forcing or social engineering. What I do know is they were under a denial of service attack, and then they got a ransom demand delivered to them via Hotmail that said, pay us some Bitcoin or we're going to shut you down. So they did what any responsible incident response team would do, is they started rotating credentials and trying to eradicate the issue. Then they got another ransom demand that said, we're serious. And just to show you they're serious, they started deleting S3 buckets and turning down virtual machines. And before the end of the day was done, they had to post this on their main webpage, basically saying, we're going out of business. Now, since that time, AWS has put various mitigations in that can help you recover your cloud if you're in this type of situation. But the main point is we need to make sure that we're protecting our credentials. In fact, if you look at the MITRE attack matrix, you'll see that compromised credentials are in basically every phase, or an attacker tactic at every phase in that kill chain. This is another one that I've been tracking because we use it as a case study in SEC 510. So back in 2019, Capital One was breached. Yeah, that's the same company that years before had made Cloud Custodian. And it wasn't because they had a public S3 bucket. It was because an attacker exploited a server-side request forgery vulnerability. The sad thing was that pivoting technique had been talked about back in 2014 by a security researcher named Andreas Riancho, showing exactly the tactic that this attacker used, and then proceeded to boast about it on Twitter. But the reason this caught my attention is because they just now reached a settlement agreement. And 100 million individuals impacted in the US, 6 million in Canada, and numerous social security numbers and linked bank accounts were disclosed. Now, here is the last one that I just wanted to mention. This was Tesla. So Tesla had an open Kubernetes console port that allowed an attacker to get in there, access some a sensitive S3 bucket that apparently had car telemetry data from the Tesla vehicles, and then they were using it for cryptocurrency mining. So again, what about Stormy? Well, you guessed it, she went on to become a cloud ace and was equipped to be able to succeed on her job. So I also wanted to let you know how to follow the SANS Cloud curriculum on social media, Twitter at Sans Cloud Sec. We have LinkedIn, YouTube, and Discord now. So with that, I wanted to leave a few minutes for questions and discussion. Anybody? Yeah.
Infrastructure as code and how that is mainly right now wrapped around just the environment that's out there. But when it comes to Azure AD, and if you're actually a Google shop, the workspace that you have that type of environment that Azure does, where you can query information here.
Mm-hmm.
When do you see that infrastructure as code extended into that realm as well? That like tenant organization level of those generic things that provide service, right? Like
Yeah. So the question that was asked was, with infrastructure as code, it's traditionally thought of as simply deploying cloud resources such as virtual machines. But then he mentioned, what about Azure Active Directory or Google Workspace? When do you see that being supported? From what I understand, you can use Terraform as an example to do your Active Directory configurations. In fact, there's a Sans instructor that is doing that to spin up environments, even on-prem, with Active Directory being provisioned by Terraform. So that's pretty cool. I personally don't know about Google Workspace, but it would make a lot of sense. So whenever there's a way to script something, even if it's not using an infrastructure as code tool, I would definitely think about that very seriously, because then it's repeatable. So I like where you're going with that. And then the second part of the question was with respect to cloud security posture management. I would think if it can be queried via an API, there's got to be a way to build either plugins or tools that can monitor its configuration on an ongoing basis. So thank you for the very thoughtful question. Anybody else? All right. Well, thank you. It was a lot of fun for me. I hope you got something out of this. We are going to make the YouTube video available. I don't know exactly how soon, but hopefully before the week is out, we can put it in the Slack announcements channel. So with that, we'll bring our keynote talk to a close. Thank you.